Okay, welcome to our Unit 1 review, and here I'm going to painstakingly go through every single problem, show you what to do. You only have to watch the examples of problems that you don't understand. Feel free to skip around. So, problem number 1, solve the following equation for x. Well, I noticed that I have an x term on both sides, 6x and 12x. So, we want to move the smaller x, and to move a positive 6x, we will subtract x from both sides. Now from here, those go away, and we have negative 12 is equal to 12x minus 6x, which would of course be 6x plus 8. Now from here, in order to get the x by itself, we always get rid of our addition or subtraction first, so I get rid of this plus 8 by a minus 8, and of course negative 12 minus 8 would give me negative 20 is equal to 6x. From here, how do I get rid of the 6? Well, I divide both sides by 6, and we're going to get this answer right here, x equals, and you want to ask yourself, can 20 and 6 be divided by the same number? And the answer, of course, is yes, they can both be divided by 2. Negative 20 divided by 2 will be negative 10 over, and 6 divided by 2 will be 3. And your answer will be x equals negative 10 over 3. At the end of each one of these examples, I'm going to move on straight away. So if you need the answer, pause the video, finish writing it down, and let's move on. Okay, here is the problem number 2. See, y'all can see that there's problem number 2. Let me switch over where I can start writing. Okay, it says write an equation for the line graphed below. Well, notice here, down here at negative 4, in fact, let me switch colors. Here at negative 4 is our y-intercept, or our b term, negative 4. Now let's talk about our slope. We know that our slope is the change in y over the change in x. And you probably want to identify the very next point where this crosses a perfect point, which would be right there. Because like, see right here, it's not on either a vertical or horizontal line. Here it's on a vertical line, but not a vertical and horizontal line. But here, it's at the perfect cross section where those two lines meet, right there. So, from this point to this point, our change in y, we're going to go up 1, 2, 3, 4. So we've gone up positive 4, and to the right, 1, 2, 3, that's positive 3. Our slope will be 4 over 3. And so, our formula is y equals mx plus b. I have my b term, I have my m term, and we'd say it's this, y equals 4 over 3x minus 4. All right, let's move on to our next example. Pause if you need to. Okay, here we are in example 3, and it says graph the inequality and write out one solution and one non-solution. And I've given you all of these solution and non-solution choices over here. So how would I graph this? Well, draw yourself an xy axis, and let's note, our y-intercept, our constant, our b term, is positive 2, so I go up 2 and I put my very first point. Now here we have a negative 3 over 4. Well, remember, your slope is the change in y over the change in x. So negative 3 over 4 is sending us down 3, 1, 2, 3, and to the right 4, because that's positive, 1, 2, 3, 4. So down 3, right 4, and we are right here. We could then go down 1, 2, 3 again, and to the right 1, 2, 3, 4. Here's our next point. Let me fill in those tick marks so we have a very consistent graph. And the last thing we'll look at is the inequality itself. It's a greater than. So since it's just a greater than and there's no line underneath it, we draw ourselves a dotted line. And once we draw that dotted line, it's greater than, we will shade above. I'll say that one more time. If it's greater than, we shade above. Now, I'm going to use a red pen, and let's take a look at our choices. So here we see 0, 10. 0, 10 means that in the x direction, we're not shifting left or right at all. We're staying at the origin. And 10 in the y position means we're going up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to be way up here, but essentially that is in the shaded region. So we would say that 0, 10 is in fact a solution. Okay. Let's go back to red. And let's now talk about 4, -1, and 4, -1. So if I count to the right, 1, 2, 3, 4, and down 1, interesting, 4, -1. 1, 2, 3, 4, down 1. I wonder if this was supposed to be on the graph itself, but it actually looks like it's not. So let me check one thing here. Since I'm the way I drew the graph, it's not the nicest or neatest. So here's what I'm going to do to check. I'm going to say, okay, this is my x value, that's my y value, and I'm going to check it like this. I'm going to say, okay, y is -1 greater than -3/4x, but what is our x term? X is 4, and then plus 2, okay, greater than. Now remember, when your denominator and your whole number are the same, they go away when they're multiplying, they cancel out, and so we have -3 plus 2, aha. And now we get -1 is greater than. -3 plus 2 is -1. So I misgraphed this. This should actually be on the dotted line itself, but you'll notice, is -1 greater than -1? Can a number be greater than itself? And no, that doesn't make sense. So remember, when you're on the dotted line, that is a non-solution. When you're on the dotted line, that is a non-solution. Okay, lastly, let's go ahead and finish with 12, -2. This will be a really easy one. So x comma y. So I go 12 to the right because our 12 is positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we're going to go down 2. And here we are clearly in the shaded region. And so that is in fact a solution. So remember, if you're in the non-shaded region, not a solution. If you're on a dotted line, not a solution. And if you're in the shaded region, always a solution. All right, let's move on. Okay, here we have our fourth example, and we want to solve the following equation for z. Now, remember our first question, can I simplify the left or the right? And we know we can simplify the left by distributing that -3. So, -3 times -8, well, negative times negative is a positive, and 3 times 8 is 24z. From here, we have -3 times 2, which will give us -6, and we say that this is equal to 12 minus 6z. Okay, now you'll think back to our first example. We know that we have variables on both sides, and we have a -6z and a positive 24z. And we want to move the smaller of the two. Well, I know -6z is smaller than positive 24z, so the opposite of -6z would be plus 6z. We're going to add 6z to both sides. A zero pair goes away, and of course 24 plus 6 would give us 30z minus 6, which is equal to 12. Now from here, we want to get rid of that minus 6, so we will add 6 to both sides. And now we have 30z is equal to 12 plus 6, which is 18. And of course, we can divide both sides by 30. Now check this out. 18 and 30 can both be divided by 6. You need to think about the biggest number possible. And 18 divided by 6, of course, is 3 over. And 30 divided by 6 is 5. And that is the answer. You will note that this was an answer choice. You have to reduce your fraction. I cannot stress that enough. Let's move on to example 5. And I was just kidding. There is no example 5 in this review. Okay, so let's look at this one. Solve the following equation for x. Okay, well, I notice here we have this exponent square, but that doesn't really change anything. We still solve in the same order. We still get rid of our subtraction first by adding. So I will add 20 to both sides, and 16 plus 20 will of course be 36. 36 is equal to 4x squared. Now from here, how do you get rid of that 4? Well, we divide both sides by 4, and 36 divided by 4 will give us 9. Okay, so we got 9 equals x squared. Now, this was one of the things that people really struggled with in the lessons. We call this a square. Oh, I'm sorry, guys. Let me turn this off. Okay, so that's a square, and we want to ask ourselves, well, what is the opposite of a square? Well, the opposite of a square is always going to be a square root. And guys, I cannot stress this enough, square and square root. All you have to do to say what is the opposite is either put the word root on or take the word root off. So from here, in order to get rid of a square, we take a square root, and what we do to the right, we do to the left. Now, I want y'all to be able to do these things by hand. So what do I mean by that? Well, the square root of 9 can be broken down into 3 and 3. And remember, with the square root, there's an invisible 2 right there. We're looking for two numbers that are the exact same. And we have that in our pair of 3's. So recall, whatever has a pair or a partner gets to escape to the outside, and anything left over stays on the inside. Since there's nothing left over on the inside here, we just say that x is equal to 3. If you're still confused by that, you can still use a calculator, but you will be responsible for this information in the near future. Moving on. Okay, here we have example 8, and let's see what would happen here. Well, on this left side we have quite a bit, but let's go ahead and start by distributing. We have 3 over 2 times x, and that is obviously going to be 3 over 2x. But what you might be a little bit confused about is, how do you do 3 over 2 times negative 8? Well, remember, we're going to write negative 8 as negative 8 over 1, and then we multiply the top by the top, so we have 3 times negative 8, which will of course give us negative 24, over, and on the bottom, 2 times 1, which is 2. Now, of course, I'm going to bring down that plus 12 and set that equal to 15. Okay, from here we have 3 over 2x minus, and what is 24 divided by 2? Well, that's going to be 12. Plus 12, dropping that down, is equal to 15. We still keep asking ourselves that same first question, can I simplify the left or right? And we can simplify by combining our like terms. Well, negative 12 plus 12 is 0, and so we have 3 over 2x is equal to 15. Now, how do we get rid of a 3 over 2? Well, we multiply by its reciprocal, which means to flip, and 3 over 2 we multiply by 2 over 3. Now, what I do to the left, I have to do to the right, so times 2 over 3, and those go away. I'll just kind of bring my answer up here, and we'll have this. X equals, and remember, you can write 15 as 15 over 1, and 15 times 2 on the top is 30 over 1 times 3, which is 3. And lastly, 30 divided by 3 is, of course, 10. See? Not too bad. Not too bad. All right, I'm going to pause this, and let's move on to our next example. Okay, here we are in example 9, and we want to solve the following expression for y. Okay, well, as always, to simplify this left side, we have to distribute. We have negative 2 times 3x, which is negative 6x. We have negative 2 times 4y, which would be negative 8y, is less than or equal to 16. Now from here, we know that we are trying to get the y by itself. So in order to get y by itself, I always start by moving my x term first. And the opposite of negative 6x will of course be plus 6x and plus 6x. That goes away, and I have negative 8y is less than or equal to, and I can just write this as 16 plus 6x. Guys, I cannot stress this enough. Do not combine, because this is the number one mistake students are going to make. This is a constant, this is a variable, all right? They're not the same. You cannot put them together. Now from here, we have negative 8y is less than or equal to 16 plus 6x. We are going to divide each and every term by negative 8. Now when I do that, that goes away, but notice we have a special rule, all right, special rule. When you divide by a negative, your sign has to flip. And by sign, what I really mean is the inequality. So see, this is a less than or equal to. When I divide by that negative, it becomes a greater than or equal to. You have to flip it. And now we have 16 divided by negative 8, which is negative 2. And of course, 6 and 8 can both be divided by 2. and this becomes negative 3 over 4x. And by the way, just for a little extra practice, what would a graph look like real quickly? Well, our b term is negative 2, so I go down 2. Our slope is negative 3 over 4. I go down 1, 2, 3, to the right 1, 2, 3, 4, here. And of course, see how it has that or equal to symbol, that line underneath? It is a straight line, and it's greater than, so here would be all of our solutions. And if you will recall, when you're on the solid line, any point there is a solution as well as the shaded region. Okay, moving on to our next example. Okay, here's example 10. Now let's go ahead and try example 10. Now it looks nasty at first, but all you have to remember is, hey, I want to distribute first, so that means that this 6ab cubed, and guys, y'all gotta learn when there's a 3 there, you gotta say cubed. 6ab cubed stays as it is, and here negative 3 times 6x squared will become, I'll keep this in orange, negative 3 times 6x squared will be negative 18x squared. Negative 3 times negative 3, negative times a negative is a positive, and 3 times 3 is 9. And of course we'll have AB, what's this 3? What do we call it? AB cubed. And then of course negative 3 times 15 will be negative 45. Okay, now I of course just dropped my negative 12ab squared and my plus 6x squared. All right, now I want to use some different colors here. Why not? Okay, let's look. We see that this ab cubed has the highest degree, so I'm going to put it first. And this also has an ab cubed, and so let's go ahead and combine these two like terms. Notice this is a positive, this is a positive, so 6 plus 9 will give us 15ab cubed. Okay. Now, since I started with my ab's, I then want to look for any more ab's. And I see, okay, you know what? That has an ab squared. So let's use a different color. Let's bring it down here. And it's negative, so I write minus 12ab squared. Okay, so I've used up that, and by the way, I've used up that, and I've used up that. I like to cross them out after I use them up. And so let's see, what's the next thing we see? Well, oh, you know what? Here's a negative 18x squared. Here's a positive 6x squared. And so remember, a negative and positives, they cancel each other out to a degree. So what is negative 18 plus 6? Well, that would be negative 12x squared. And because there's more negatives, our final answer is still negative. Okay, so that's gone and that's gone. And of course, then I can just drop that minus 45 because it has nothing to combine with. All right, and so your final answer should be this: 15ab cubed minus 12ab squared minus 12x squared minus 45. Now, apparently, I was feeling really negative at the moment. Ha-da-da-cha. Okay, let's move on to our next example. I'm kidding. That was the last example. Hey, really take this review seriously, and if you can do every problem here, you're going to crush it on the test. All right, good luck, y'all. And we'll have a test on Monday and Tuesday, depending on 4th period or 6th period. And guys, show up on time. You are only able to take the test during my Zoom class. All right, thank y'all.